Hiya, I'm Car, and I'm gonna talk about power and type 1 and type 2 errors. So a type 1 error is a false positive, aka we reject the null when the null was actually true, and that is literally just our alpha level. So if we have an alpha level of 0.5, it means that there is a 0.5 chance, so a 5% chance, that we have a type 1 error. Meanwhile, the type 2 error is a false negative. We fail to reject the null when the null was actually false, which is our beta. But how do we get that beta? Well, that is 1 minus power. What is power? Well, that is the chance of correctly rejecting the null. So we want to have high power. That is our goal. So that is the goal of this video, of how to get this power and how to calculate our type 2 error based on that power. Getting power takes a bunch of steps, which sucks, but I'm gonna walk you through it. So let's go over it. So how to find power of any given alternative hypothesis. So the interesting thing about power, we can literally choose whatever it is. We can choose any alternative hypothesis. So the building blocks that we're going to be using are going to be our standard deviation, our sample size, our alpha level, our null hypothesis, and our alternative hypothesis. Those are the building blocks with which we are going to make the whole thing. So there's a few steps to getting to our power, one of which include getting a thing called a critical X value. So how do we do that? Well, first step, like always, step 1 is getting our hypotheses. So that is our null hypothesis versus our alternative hypothesis. It's the normal thing that we always do. Then we find our z, which is based on our alpha level. And then we find our critical x by basically combining our null hypothesis with a margin of error. So it's basically like looking at a confidence interval. So it's a confidence interval with an extra step. It is our null plus our z times our standard deviation divided by the square root of n. So you can see this is like the same thing as a general confidence interval. We just add that to our null hypothesis, and that is our critical x. Then we need to find our z-score for our power. You do that by doing z is critical x minus our alternative hypothesis, which we're going to choose by ourselves. We're going to go over that when we look at the example, divided by the standard deviation divided by n. And then we look that up in the table. When we look that up in the table, we now have our power. This result over here is going to be our power. Then it's 1 minus power is our type 2 error. And our goal is to have as high as power as possible, so our type 2 error rate is going to be as low as possible. So we're going to go over an example now. So let's go over that. I've written down a little example. So, is exercise good for your health? It's suggested that the average health score of people is 60 with a standard deviation of 10. We assume that people who exercise regularly have a score of 75. We want to find the power if we ask 50 people and we have a alpha level of 0.5. 0.05. So let's look at the building blocks. What do we have here? So our null hypothesis is going to be the average that we had. So that would be 60. We found that the standard deviation is 10. We also have our alternative hypothesis over here of 75. That is the one that we choose. This one is arbitrary. We could also choose 80. We could use 65. We could use 50. We can choose whatever. Then we're going to look at our n score. We want to ask 50 people. So if we ask 50 people, what would be the power of this example if we ask 50 people? And our alpha level is 0.05. So now let's go through our steps. So step 1 is always going to be our hypotheses. So our hypothesis, our null hypothesis is that the average of the true elected population is 60 versus our alternative hypothesis, which is our average is higher than 60. That is the first step. Then we need to find our z value for this one. Well, we can look over here at our tables and stuff, and we find that if we want to have this much confidence, let's see over here. Actually, no, this would fit better over here. So this much confidence, because that is the same as the 0.05, 0.05, that would be 164. So 164 is our z value. So now let's plug that in to get our critical x. Critical x, which was our null plus our z value times standard deviation divided by the square root of n. Let's plug that in. So that's 60 plus 164 times 10 divided by n, which gives us 62.32. So that is now our critical x value. So let's go plug that into our z to find our z for our power, which was our x, like our critical x, I'll say cx, minus our alternative hypothesis, which is this one, divided by the standard deviation divided by n. So we're going to plug that in, which is 62.32 minus 75 divided by 10 divided by the square root of 50. And from that we get minus 5.4358. Then we're going to look that up in our table. It's this one. So let's look at our table. And we find that it is really, really, really small because it's somewhere over there. So that is almost zero. So that is 1 minus like almost 0. So 0.00, which would be almost 99.99999, whatever. It's very high. So this is our power. Our power is 0.99999. Now, how do we get our type 2 error? It's 1 minus 0.9999, which is very small. Once again, very small. So that is what we want to see. We see that if we have our alternative hypothesis of 75, and we asked 50 people with a alpha level of 0.05, our power to correctly reject the null is very, very high, which is exactly what we want. And we see that our chance of a type 2 error is very low. And that's exactly what we want. So yeah, that is basically it. Just try to keep in mind that there are a lot of steps within the power and stuff. This one is once again just a lot of do it quite often to memorize the steps. Keep in mind you have to find the z-score twice, once for your alpha level and once for your power. And yeah, that's basically it. I hope this was helpful.